Hi all, I hope your week went well. Overall, chapter 6 was my favorite chapter so far. I wanted to be a hurricane hunter when I was younger. Um, I used to sit and watch the Weather Channel for hours on end. The movies about the weather and the events about the weather and the weather itself, I would just watch it forever. I decided not to be a meteorologist though, so this chapter was a nice remembrance for me and a nice review of the material that I learned in 8th grade surrounding El Nino. I remember a video specifically where they all go like El Nino. And I remember my whole group doing that forever afterwards. So this chapter was fun for me. I broke it down into 3 sections. First is the general characteristics of the Earth's atmosphere and oceans. From this section, I learned that ice up to 2 meters thick can be formed in one season, and it is limited by the latent heat of fusion being conducted out of the ice. This also increases the salinity of the seawater below, and snow actually insulates and slows this process down. I thought it was interesting that ice can become fresh enough to drink as the seawater escapes, and I'd like to know more about how this works and the potential of using ice or sea ice as drinking water. I also learned about the Earth's heat budget and how it works to maintain a surface temperature of 16 centigrade. Out of 100 radiations received, 30 is reflected, 51 is absorbed by land, 19 is absorbed by the atmosphere, mostly of which goes to water vapor, the CO2, and dust. I thought it was interesting that we receive 1.6 calories per centimeter squared per minute of radiation energy from the sun at a 90-degree angle, so only on Cancer and Capricorn, and that it would actually be 2 without the atmosphere. And I thought that was interesting to learn that it would only, honestly, I thought it would be a higher change than 0.4. I know that it's still significant in affecting the wildlife and us. I just, for some reason, always thought it would be higher. I also learned about the Antarctic ozone hole. For some reason, I just didn't know that this existed. I always thought the hole in the ozone was only the CDCs and caused by us and everything. I didn't know that there was a naturally occurring one that occurs at temps lower than negative 80 Celsius. And this is a 70% reduction in area of the ozone due to the chemical reactions in the clouds of the stratosphere. I also thought it was interesting that the book states that we've reached the max levels of CDCs in the troposphere because we've stopped using them to a point, but that these chemicals are still migrating to the stratosphere. So the effects of the greenhouse gases that we released earlier in this century and the 1900s, since the Industrial Revolution, are still going to increase the surface temp for years to come, even though we stopped being so awful, I guess. The second chapter, or second section that I put this chapter into is the atmosphere in motion. I learned about the Coriolis effect, which is the detection of moving air relative to Earth's surface. It depends on an increase in altitude, the speed of the air, and the rotation rate. This is 0 at the equator, and it also measures for ocean currents. I also learned about the different winds, such as trade winds, the westerlies, and the polar easterlies for both hemispheres. I didn't think that the wind was supposed to only blow one way, most because you check the weather and it's like north, northwest, south, southwest. It always changes. I thought it was interesting to learn that without the topographical effects that they would blow straight forever. I also learned that the low pressure systems are over the warmer section, so that is the land in the northern hemisphere summer and the ocean in the northern hemisphere winter, or the ocean in the southern hemisphere because they lack seasons due to the lack of land. I also thought it was interesting to learn that the monsoon effect can be felt on a smaller scale on lakes or coastlines, because I hear the word monsoon and I think lots of rain. I didn't think that it could be applied on a smaller scale. And the orographic effect, which is the control of precipitation patterns due to elevation changes, making it wetter on the windward side of a mountain. I always knew that the mountains had the two sides, as evident in all of the cities stated in the book, but I did not know exactly why, and it's due to the air being pulled up quickly and then condensation being higher than evaporation. The last section of the book, which was my favorite section, is I called it effects on weather. Hurricanes, I thought it was an interesting fact was that hurricanes cannot form on the equator because the Coriolis effect is needed for the rotation of the winds. And that Hurricane Rita is the strongest measured hurricane in the Gulf, but it weakened before it hit the land. And I have here that they mentioned the Galveston hurricane. They call it, they say it was a storm surge or tide that hit Galveston, Texas in 1900 and killed 5,000 people. But I actually did a report on it in 8th grade, and it was the deadliest hurricane to ever hit the United States. It actually killed more than 12,000 people. They don't know the exact number because the way that they got rid of all of the bodies was by just throwing them into the ocean and burning them and burying them. There were so many they didn't know what to do with. There's actually a documentary on it somewhere on the Weather Channel if you're interested. Yeah. I also learned that the West Pacific is warmer and sits higher than the East Pacific during normal conditions, and these change due to the Southern Oscillation. I also learned that El Nino is named the way it is because it usually occurs around Christmas. And this entails warmer winters and lots of rain for the Eastern Pacific areas. And I did not know that there's an opposite of El Nino, which is La Nina, which is dry and cold conditions for us. So that was the chapter. Overall, I thoroughly enjoyed it. My 3 questions are as follows. 1. In 1987, it was determined that a large tabular iceberg from Antarctica would have provided everyone on Earth with 2 glasses of water daily for 2,000 years, or all of LA for 100 years. Is this a possible source of drinking water as climate change pushes the world water crisis to extremes? And would the impact on the environment or sea surface levels be too severe? Would it be too costly? Because you'd have to tote icebergs around or melt the water at the iceberg and ship it elsewhere. 2. Clouds reflect the short radiation waves from the sun, yet allow the escape of the long radiation waves leaving Earth. Therefore, would forcing clouds to form in the troposphere be a good way to help readjust the ozone, atmosphere levels, and the Earth's temperature? What steps has society taken to combat the increasing surface temperature of Earth now that we've decreased our CDC output? And 3. The book mentions that the multivariate ENSO index has been used somewhat accurately in the past to save the U.S. millions of dollars before the switch to El Nino. However, it has also failed. What influences El Nino to be different every time, and what steps must be taken in preparation for El Nino to save the money? Thank you for watching. Have a great weekend.